Hi everyone, in this video we'll be talking about graphing, plotting three-dimensional coordinates and the three-dimensional coordinate system. So let's get right into it. As you see in this image, there are three axes. We have our x-axis, our y-axis, and our z-axis. These three directions would be the positive direction, as you see from the little tick marks. So what happens is each ordered pair in the three-dimensional coordinate system has, of course, three components, an x coordinate, a y, and a z. So let's just talk in general about that right now. So with the positive x-axis this way and the positive y-axis, I would like you to picture yourself as this plane right here as the traditional xy plane as you know it. So with this as the traditional positive y and positive x, if you were to go ahead and plot a parabola like y equals x squared, it would look something like this. And it would be almost like you, this is your face, looking at a board on the wall this way. So the z-axis is actually coming out of the board straight into your face. Okay, I'd like you to take that image with you. Now, there are many different representations of the three-dimensional coordinate plane. Actually, this is coordinate space. It's no longer a coordinate plane, it is coordinate space. There are a couple of different ways to represent the x, y, and z axes, but this is going to be the standard we base ourselves on, and we would like to have some fluidity in there. As you'll see, we'll use some graphing utilities in class time to show how the x, y, and z axes are fluid and can really be pointing in any direction you want. So I'd like you to take with you, though, from right now, that this shaded red plane would be quadrant 1. So therefore, this would be quadrant 2, quadrant 3, and quadrant 4 down there. So that's hopefully we get a good vantage point for that. All right, so now in coordinate space, we don't have quadrants anymore because there's more than 4 spaces. So I'd like you to imagine that a space can live on top of quadrant 1 and below. Here's a good visual for that. So if this were the positive x-axis, positive y-axis, and positive z-axis, we have, well, there's 8 of them, so these are no longer called quadrants, but octants. We have an octant floating above the first quadrant, which would be the first octant. We have an octant floating above the second quadrant, which would be the second octant. We're going to work our way around. Third octant, I'm going to get rid of that. And the fourth octant, again, floating above the gray XY plane. So below the first quadrant would be the fifth octant. Below the second would be the, you guessed it, sixth. The seventh is completely out of the picture. Seventh is hidden. And then down here would be the eighth quadrant, or octant. If I'm saying quadrant, I meant octant, meaning 8. And just as a quick reminder, this is the positive x, positive y, and positive z axes. All right. So again, we'll play around with this a lot in class, but hopefully this will set the foundation for some intuition going on here. So let's get to actually plotting some points on the 3D space. So let's check out an example of plotting some 3D points. Let's take a look at point A here. So point A is 9, 6, -2. Let's just take the 9 and the 6 for just a quick second. As we talked about previously, the positive x and positive y values here mean that we can envision the traditional 10 by 10 that we draw often. This would be our traditional xy plane. So let's use that to our advantage. Let's ignore the -2 for a quick second. And if we were to go ahead and plot 9, 6, we would go 9 units in the positive x direction. We would go 6 units in the positive y direction, and we would use a grid to find the point in space where they line up. Well, here it's really important to be operating parallel to axes. So what this is saying is that this distance 9 is the same as this distance 9. And so that's this distance 6 and 6. So this would be the point 9, 6 on a two-dimensional plane. Again, if we're up here by the z looking at the board. So now let's deal with the -2. The -2 means it is 2 units down from the xy plane. It is 2 units behind the whiteboard that we're looking at. So what we can think of is it goes down 2 units, down 2 units. So we're actually looking at almost like a prism here. So if this was a book, it would be, 2 units thick starting at the whiteboard and going 2 units behind. So where's the actual point A, 9, 6, -2? Well, here's where you got to follow it. 9, 6, -2. So this point right here is point A. Right? Let's check out point B and make some sense of this. -4, so -4 in the x direction, -7 in the y direction. Oops, I just counted 8. 5, 6, 7. So again, I like to make a little parallelogram. From this vantage point, our parallelogram is actually a rectangle. And then this one is going to be 5 units above that first plane. So we're going to go up 5. Go up 5. Right, so we're giving it some depth in this particular way. And so which point is point B? It is this one. So we're going to picture this shaded region, this shaded plane being 5 units above the XY plane. So there's your 4, -7, +5. So continue on with C and D. We'll get a fresh start for each of our set of 2 here. So again, I'm not gonna talk through every single step. There's your -8. There's your 5, +5. Okay, so there would be 8, +5. And now 4 units up. So here would be the 4 units up. So we'll post that 4 units up like this. And again, it'll be this point right here. There's point C. Forgot to label point B in our picture over here. And there's your, gotta get back to my color here. 4. And then finally, let's look at how to plot point D. +6 in the x direction. -7 in the y direction. And then -8 in the z direction. Means we're going down 8 from here. So this plane right here is floating 8 units below this plane, which would be on the XY axis. So here is point D in purple. All right. So like I said, in class, we'll look at a lot of these and we'll use some 3D graphics software to really get a dynamic look. Now let's take a moment and find the length and midpoint of a segment that connects 2 points. We've done that plenty in geometry class. Let's check it out. So the length of a midpoint, or the length of a line segment, of course, is the Pythagorean theorem. Well, it actually works in exactly the same way in 3 dimensions as it works in 3 dimensions. So let's go ahead and do that. The length of JK is, well, first things first, let's find out, how do you get from J to K? So it's almost like we want to look at the vector from J to K. So to get from J at positive 7 to negative 9, you would do negative 9 minus 7. You would do 4 minus negative 8. And you'd do 3 minus negative 5. And putting it in terms of a vector is really, really helpful because it gives you the components. How do you get from point J to point K? So we've got negative 16, negative 4, and 8, which is nice. So now the magnitude of that thing would be the distance, okay? So, which would be the square root of the squares of the components. So the magnitude of JK. I'm realizing that I made a notational error here. If we're going to call this thing a vector, we do need to put it in angle brackets. Sorry about that. So the magnitude of vector JK, 16 squared plus 4 squared plus 8 squared. You can include the negatives if you're so compelled. So let's grab our calculator. 256 plus 16 plus 64 equals the square root of 336. So we can reduce that thing. First things first, it's definitely not a perfect square, but in case you don't know that, it's cool. You can try it. Nope. Oops. Oh well. So 336. Let's see. 16 looks like a pretty good candidate for a factor. Yep. 21. So 336 would be 16 times 21, or 4 times the square root of 21. Of course, we can always go for the approximate 18.3 as our final as well. Now, midpoint. Midpoint's probably something you haven't thought too much about since geometry. Midpoint is just the average x value and the average y value, of course. So to find the midpoint, we'll call it m. We would just do 7 plus negative 9 divided by 2, negative 8 plus 4 over 2, and negative 5 plus 3 over 2. So the midpoint would be, what is that? Negative 2 divided by 2 is negative 1. Whoa, what's going to happen here? This is going to be pretty cool. Negative 1 and not negative 1. Negative 2. Sorry about that. That's why I was a little confused there. And then finally negative 1 as well. If you want to go ahead and plot that, I welcome you to do so. I'll see you in class very soon, and we'll talk more about all of these things.